All right, pre-calc. This is the second part of lesson 5.3. So in the first part, we were solving these trig equations and we were solving them over this interval. Now, some of you would have noticed, I think, when you looked at your graded homework worksheets, that if you found an answer set to be 0 and 2 pi, I wrote on your paper that these are the same and that we don't want to include 2 pi. And that's because if you look at your interval, you only see the bracket on the 0, which means we include 0, but we don't include the 2 pi. So just keep that in mind. As we move forward, you're going to see that the directions are going to switch, and they're going to say things like, just solve. And basically, what that's going to mean to you is that you have to give infinite answers, and there's a specific way that we say that. You're going to be doing a lot of the same things, techniques we've used before, or using the same techniques from before, like factoring and so forth. So let's go ahead and factor this first one. Factors of -2 that add to -1 are going to be -2 and 1. So if you're familiar with the bottoms up method, we would start it off like this. And then because there's a 2 right here, we'll divide everybody by 2. We'll reduce this fraction. And then we're going to go ahead and solve each factor. Set them equal to 0. All right. So the initial parts of these are the same as what you've done before. You would say here that x is pi over 2, and here x is -1/2, or sine is -1/2 in our third and fourth quadrants. But this is where it's a little bit different. What you need to consider is that pi over 2 sits right here on your unit circle. Pi over 2 has a sine of 1. But so does an angle coterminal to it. So if I added 2 pi to it and had 5 pi over 2, that also would have a sine of 1. Or if I started here and I went backwards and I subtracted 2 pi, I would still have a sine of 1. So in order to account for all of the answers, you have to take pi over 2 and you're going to add a complete circle to it. So that's 2n pi. All right, let's try that over here. So I'm going to start off by putting 7 pi over 6 right here. 11 pi over 6 is right here. If I want to start here at 7 pi over 6, the only way I'm going to get back to that angle is to draw a complete circle. So I'm going to add 1 revolution. Likewise, if I start here at 11 pi over 6, the only way I'm going to get back to it is by adding a complete circle. So that's 2n pi. So for now, you've noticed that I've just added 2n pi, which basically just gives you a coterminal angle. All right. We're just going to skip over number 7. There's some other things I want to show you that are more important than that one. Let's go ahead and do number 8. All right, you guys have been doing a lot of Pythagorean identity substitution. So if I take out tangent squared, what would I put in its place? So that's the same as secant squared x minus 1. I'm going to go ahead and bring this to the left and bring that to the left. Then clean it up. I'm going to factor out a secant x. And I'm going to set each factor equal to 0. So if secant x were 0, that means the cosine of x is undefined. Cosine is not undefined ever, so that piece is no solution. But if the secant is 1, the cosine is also going to be 1. And cosine is 1, at 0. If I put 0 on my unit circle, it's right here. If I add 2 pi to that, I'm right back at 0. So I'm going to add 2n pi to that. Now, that's the same thing as just 2n pi. So when n is 1, that's 1 trip around the circle. If n is 2, then that's 4 pi, and the cosine of 4 pi is still 1. So again, you're just naming a whole bunch of coterminal angles. All right, I'm going to introduce here a few more problems. We're going to look at number 25. So up here, I'm going to put 25. I'm going to take and factor that again. So factors of -2 that add to 1. Divide by 2. Set my factors equal to 0. And cosine is -1 at pi. Pi sits right here. If I want to get back to pi, I'm going to have to add 2n pi to that. Cosine x equals 1/2. That's true at pi over 3 and 5 pi over 3. Well, let's kind of think about where are those at on my unit circle. Pi over 3 is up here. 5 pi over 3 is down here. If I start here at pi over 3, the only way I'm going to get back to that is to add a complete circle. So that becomes pi over 3 plus 2n pi. And this becomes 5 pi over 3 plus 2n pi for the same reason. So right now I think you can figure out that if two angles are not 180 degrees apart or 90 degrees apart, you're going to have to add 2 pi in every time. Okay, I'm going to pause this video right here. I'm going to do a second video with another question out of the textbook and then a bunch of what-if statements. So you'll see a more variety or some more ways to write your answers, like what if the answers are 90 degrees apart? What if the answers are 180 degrees apart? And so forth. So we'll get to those in the next video.